let us resume our IoT tutorial video. So from in this particular video, hi there, welcome back to the IoT video tutorial. So here I will explain the interfacing of the sensors to the IoT weather station. So here you can see the Node MCU 8266 microcontroller interfaced with the DHT22 humidity sensor. Now, as we have already discussed, this is a one-wire interface or one-wire device. So we need this 4.7K pull-up register from the data bus, that is this blue color line, which is connected to the pin D4 of the Node MCU to the VCC or the 3.3 volt line. And once that is done, the rest will be controlled from the program itself. And this is the program of the DHT22 humidity sensor. So first we declare to which pin the program is connected. So that's D4. So that is declared at this point. And which type of sensor we are using. So there are many types of DHT devices. So we have to declare them here. Now this library is made by Adafruit. So you can use that. It is a very well-known and easy to use library. Now once you do that, it becomes really simple to use the humidity sensor. As here we can see, of course we have to initialize the serial terminal because I want to show the data from the sensor in real time, and then this will print this DHT test, and DHT begin this thing. It initializes the one wire bus, and here also it tests whether a valid DHT device is present in the one wire bus or not. Now there is a 2 millisecond delay here, so that the data will be read from the sensor after every 2 seconds. Sorry, not 2 milliseconds, it's 2000 millisecond or 2-second delay. So first we declare these variables where this humidity value will be stored. So they are all float type. So we declare them float age equal to, and you can directly assign them the value reading. Now you could also declare the variables first, like outside the program, and just use them. So anyway, DHT.read humidity, this function, it reads the humidity and stores it in Celsius format. You can also, it reads the humidity and stores it, and DHT.read temperature, it reads the temperature and stores it in Celsius format. You can also read the temperature in Fahrenheit using DHT.read temperature inside bracket true. So this true is Fahrenheit equal to true, each Fahrenheit. So this flag, once you pass on this flag, then it will store the value in Fahrenheit format. After that, here if these values that we read from the sensors are invalid, so which can happen if there is a failure to read the data on the sensor due to many reasons. One of them being the signal is not stable or the sensor is hanged. So anyway, if there is no error, then the program can proceed. So here we can also compute the heat index. This is being taken care by the library itself, and those things can be printed as well. So here I have written this humidity to print the humidity, temperature in centigrade as well as in Fahrenheit, then heat index in centigrade and Fahrenheit. Now we can see the real-time data from the sensor that I have recorded as a GIF image. So here you can see the humidity is 96%, temperature is 27 degrees centigrade or 81 degree Fahrenheit, and heat index is this much. So now we know that DHT22 sensor is working, so you can use it in our weather station. Now let's switch to the next sensor. Next one is the BMP280 pressure sensor. So it has an I2C interface. That means this SDA and SCL, serial data and serial clock lines, they need to be connected to the this is the sensor, so they need to be connected to the SDA and SCL on the Node MCU. Now in this case, Node MCU can configure any of its digital pins as SDA or SCL. That has to be done from the program side. Now once we have connected it like this, and also apart from the data lines, that is the SCL and SDA, it also needs this VCC and ground, that is the power supply 3.3 volt and ground. The ground must be shared between the microcontroller and the sensor. So here is the program to test the BMP280 sensor. Now again you have to initialize the proper libraries as seen on this the top two lines. Then we have to declare the address of this sensor. As all I2C devices, they have the same, they have different addresses and they all share the same bus. So they must have different addresses to be able to communicate with them. Then we initialize the sensor like this. Here you have instantiated the sensor, you have not initialized it yet. In the setup section, we will initialize the sensor here in this case. Now, if the sensor was initialized properly, then fine. If it was not initialized properly, then we should see an error message that could not find a valid TN280 sensor. It is useful in case later on you will be wondering why I have connected my sensor but still I am not getting any data. So that's why this type of code is very useful. And then in the loop section, we will just read the temperature using this bmp.read temperature function. Similarly, this predefined read pressure function. These functions are declared in this Adafruit library. So it makes it really easy. Otherwise, you have to read the serial data that is coming as a digital stream of data. Then you have to pass the data to find out the temperature and sensor. So the program will become very lengthy if you do that everything. So it's easy to just use the existing program which has been verified by many. Serial print, then you can print the altitude by calculating this altitude. So this function, it calculates the altitude by checking the pressure against the pressure that we declare as the sea level pressure. So we will just print those things in our serial terminal. Here you can see it is a recorded GIF image when I was developing verifying the interfacing of the BMP sensor. You can get the temperature, the pressure in Pascal, and the approximate altitude of this location from sea level. Next, we will set up this dust sensor. So this sensor, you have to set up this pulsing circuit like this using a capacitor and a resistor according to its dataset. And once this is done, so what we are basically doing is we are turning on this LED, the infrared LED inside the sensor for a specific duration, that is a few microseconds, and within that time we are measuring the voltage generated by the photodetector. So this method is used, this is done to increase the life of the infrared LED so that the sensor can work for a prolonged period. Otherwise, if you keep the LED on all the time, then it won't last very long. And since this is a relatively expensive sensor, so it's better to use it in a pulsed manner, like as shown in this figure. Now here is how the program will work. So again, we have to declare a pin where this the sensor will be connected. So this pin will be this one, as we have already discussed, that is an analog sensor. So it will be connected to the A0 pin, and I want to turn on an LED. So that LED pin is D2. So while we are measuring the this D2 is the this is the LED inside the sensor, the IR LED, infrared LED. So we have to turn it on using a pulse. So we will see how that is done. And of course, now here I have declared the variables that will store the data, and declare this value. It is needed for the calibration, that is what is the output voltage at zero dust. So it has to be calibrated at different places, so this value will change. And now this k equal to 0.5, this is needed for the linearized equation. Now after that, we just initialize everything, initialize the serial terminal where we will print the measured value. Then we declare the LED pin, that is the infrared LED, as an output device so that we can turn on and off later on. Now here is the main loop. So this is how the voltage is read. So first we turn it on for 280 microseconds. During that time, we read the dust pin or the sensor pin or the analog voltage or the ADC voltage. Then I have written this little loop to average 10 readings. Now once I got the average value, then I can find out the voltage by this formula, this linearized formula. Now that voltage, this is the voltage that is converting this ADC value into a volt. So this volt, to find out the dust density, we have to convert this voltage, the change in this voltage, to microgram per meter cube using this formula. This is the linearized formula to get the dust density. Now once we have found the dust density, we can print the different parameters like the raw voltage, raw signal value or raw ADC value, then the calculated voltage for that ADC value, and the dust density according to our formula, and verify it according to or with respect to a reliable source to be certain that our sensor is working fine. Now you can print a delay of 5000 milliseconds so that it will be done only once in 5 seconds. Now to test the dust sensor, so we can see here the raw signal value is 293, so it is updating at every 10-second interval. That's why it's coming up slow. Now this is a recorded GIF image again, so it's not live anyway. So from here anyway we can see that the sensor was working as expected. So dust density is right now in this location is about 160 microgram per meter cube, and it's a residential area near relatively busy area of the city, so it was understandable. It's okay. In the next videos we will see how to set up the IoT and MQTT server and transmit this data, the sensor data, the temperature, pressure, humidity and the dust sensor data to the VPS server. So see you in the next slide.